Welcome back to CircuitMeter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in.
Imagine, just for a second, that your office building, or the massive factory down the road, or even your favorite local retail store. Imagine it isn't just a physical structure made of steel and concrete.
Right, which is how we usually think of them.
Exactly. But imagine it's a live, interactive video game dashboard. You are looking at a perfect, virtual 3D model of your physical system right there on a screen, and you can see every single thing happening inside of that building in real time.
I mean, it sounds like pure science fiction, honestly.
It really does.
Like you're watching a futuristic movie where the head architect is hovering over this glowing blue hologram of a city, twisting dials in thin air.
Yeah, but here's the crazy part. We aren't talking about movies anymore. This concept is fundamentally rewiring how businesses operate today, like in the real world. So welcome to the deep dive.
We are exploring why digital twins are the inevitable future of infrastructure and how a specific technology from CircuitMeter is the essential fuel, the lifeblood powering that entire future.
It is a critical shift, because we are looking at research today outlining how the physical world is merging with the digital. And this isn't some theoretical whiteboard planning for 10 years down the road.
Oh, it is happening right now.
Right, it is happening rapidly. It is transforming infrastructure across the globe. And, well, it requires us to completely rethink how buildings and facilities operate.
Okay, let's unpack this, because the term is everywhere right now. At a surface level, a digital twin is defined as a virtual replica of a physical asset. And looking at the sheer scale of deployment happening right now is just fascinating.
It really is staggering.
I mean, we are talking about massive global enterprises building entire alternate realities of their operations.
Yeah, BMW is a prime example of that momentum. They haven't just modeled a single assembly line. They have created fully operational virtual versions of all 31 of their production sites.
Wow, all 31.
All of them. They utilize these digital environments to simulate scheduling and production down to the individual work order level. So before a single piece of actual heavy machinery moves on the physical floor, they've already run the scenario digitally to see where the bottlenecks form.
And it isn't just heavy manufacturing getting into this space either. The retail sector is diving in with equal aggression.
I mean, you have massive retail chains like Lowe's deploying digital twins supercharged by artificial intelligence. Their planning teams are physically putting on augmented reality headsets to walk through a digital replica of a store. It allows them to analyze spatial layouts, test how foot traffic might flow around a new promotional display, and optimize every inch of shelf space.
And they do it without ever forcing employees to physically move thousands of pounds of inventory just to see if a layout works.
And if we connect this to the bigger picture, the applications extend deep into essential municipal infrastructure, which affects all of us.
Yeah, that was wild to read about.
Thames Water, which manages the supply for millions of people across the London area, mapped its massive labyrinthian water network. They use their digital replica to simulate the effects of various repair methods.
And finding leaks.
More importantly, yes, they use it to hunt down invisible leaks. By comparing the expected water pressure in the digital model against what is actually happening underground, they can pinpoint fractures in the system that were previously impossible to track down.
The scale is staggering. 31 factories, 1,700 retail stores, entire municipal water grids.
But we have to draw a hard distinction here.
We do, yeah.
Because the reality is a massive wave of early digital twin projects completely failed. They were abandoned or, totally underutilized.
Almost entirely wasted investments in some cases.
And that brings us to the most vital concept in this entire discussion. A digital twin is not a mirror. It is a control layer.
That distinction changes everything. A lot of those early projects failed because they were really just glorified 3D architectural renderings.
They were static snapshots in time. You could spin the building around on your computer screen, zoom in on a beautifully rendered air conditioning unit, but the model didn't actually do anything to manage the physical asset.
It was just a picture.
Right. To be a true digital twin, it must be an active operational control layer that responds to the physical world in real time.
Wait, so if a digital twin isn't just a fancy 3D visualization, how does it actually make the leap to controlling a building? What is missing?
Well, the missing link is live operational data. You simply cannot control what you cannot measure in real time.
That makes sense.
If the beautiful 3D model on your screen doesn't know what the physical building's HVAC system is doing right this very second, it cannot act as a control layer.
Here's where it gets really interesting. A static 3D model is basically like a GPS app that lacks live traffic updates.
Oh, that's a really good way to put it.
Like, sure, it shows you where the road is, but it won't help you avoid the 5-car pileup that happened 3 miles ahead, 10 minutes ago.
That is a perfect analogy. What's fascinating here is that without live operational intelligence, these digital twins fail to deliver on their promise.
Which brings us directly to the foundational layer. The research positions CircuitMeter as the essential energy data layer for these systems. If the digital twin is the brain of the facility, CircuitMeter is the nervous system.
The nervous system analogy works perfectly here. A brain is useless without constant instantaneous feedback from the body.
Right. It needs to know if a hand is touching something hot immediately and not like 5 minutes later.
Exactly. CircuitMeter provides that immediate feedback by capturing live power usage directly at the source.
It isn't relying on estimates or algorithms or waiting for a monthly utility statement, is it?
No, not at all. CircuitMeter captures this live power usage straight from the circuit breaker.
So it is literally taking the electrical pulse.
Yes, exactly. And then it updates this granular data in the cloud every 2 seconds. What's fascinating here is that the 2-second ping isn't really meant for the human eyes to process manually. It is built for the system itself.
Oh, I see.
This is where advanced software ecosystems come into play. Companies like BizTech use CircuitMeter as a strategic partner for their back-end services. They take that instantaneous data and feed it into what they call agentic AI ecosystems.
Agentic AI, meaning artificial intelligence that doesn't just sit there and analyze data, but actually has agency. It takes action.
Precisely. Let's say a massive cooling unit in a co-location data center suddenly drops its power draw. A human might not notice it on a dashboard for 20 minutes.
And in a data center, 20 minutes is an eternity?
Oh, 20 minutes of lost cooling means servers start overheating and failing. It's a disaster. But an agentic AI system receives that 2-second pulse from CircuitMeter, instantly recognizes the power drop, and automatically reroutes cooling from another zone.
Or spins up a backup unit?
Exactly. Before the human operator even knows there was a problem. The AI can only take that agency if the data is accurate and instantaneous.
So it's not about overwhelming the human, it's about empowering the automation.
Exactly right.
And the way this data actually gets from the circuit breaker into these AI brains is through a standard open integration layer, an API. It doesn't require ripping out the building's existing software.
No, it's designed to be seamless.
CircuitMeter just feeds this real-time electrical pulse directly into the building management systems that are already in place. It bridges the gap to the digital twin.
And this raises an important question regarding why this specific speed is so revolutionary. Historically, building operators relied on traditional interval data or standard monthly reports.
Which is way too slow.
Think about that for a second. A monthly report is an autopsy. It is forensic. It tells you that you wasted energy or had a mechanical failure 30 days ago.
Too late to do anything about it.
There is nothing you can do about it except pay the penalty.
It's the difference between doing an autopsy and wearing a fitness tracker. Traditional data tells you why the machine died last month. CircuitMeter is the fitness tracker that tells you the machine's heart rate is spiking right now, so you can intervene before it actually has a heart attack.
That is the crucial shift. CircuitMeter bridges the gap between theoretical planning and physical reality by providing second-by-second truth. It moves operators entirely out of the business of reacting to the past and puts them in the business of managing the present.
Okay, so that sets up the architecture beautifully. We have the digital twin, which acts as our centralized brain. We have CircuitMeter acting as a nervous system, pumping real-time data into that brain every 2 seconds.
Right.
But I want to ground this in everyday reality for you, the listener. Now that the digital twin has this real-time pulse, what do humans actually do with this dashboard on a random Tuesday morning? How does this alter the day-to-day reality of running a complex facility?
The practical applications are incredibly broad, and they are actively being used across a massive variety of sectors right now.
Everywhere from factories to offices.
Yes. We are talking about the industrial sector, municipal infrastructure, data centers, commercial real estate sectors, and co-location data centers. Every single one of these environments has complex electrical needs, tight margins, and essentially zero room for error.
Let's break down some specific examples of what these capabilities look like in the field. One of the most common and frankly most expensive issues highlighted in the research is catching control errors.
Oh, control errors are notoriously difficult to spot.
Yeah, they are practically invisible.
You could easily have a scenario in a manufacturing plant where a massive industrial exhaust fan was accidentally programmed to run 24 hours a day, 7 days a week.
When it shouldn't be.
Right. In reality, it only needs to run during a specific 8-hour manufacturing shift. Because the fan is hidden away on a roof or in a utility room, nobody notices it is running constantly. You don't find out until a massive utility bill arrives weeks later.
The research gave another incredible example of this. A cooling system mistakenly fighting a heating system in the middle of winter.
That happens all the time.
It happens all the time in commercial real estate. Someone adjusts a thermostat, a sensor drifts out of calibration, or a control zone overlaps. Suddenly, the air conditioning kicks on and starts blasting cold air to cool down the heat that the furnace is desperately trying to pump into the exact same space.
And without real-time circuit-level visibility, those two systems will sit there and quietly fight each other for months.
It's just burning money.
Burning massive amounts of energy. The building occupants might not even notice because the room temperature feels somewhat normal, but behind the walls, you were just wasting power as the systems war with each other.
But with CircuitMeter feeding the digital twin, that simultaneous power draw on both the heating and cooling circuits triggers an instant anomaly flag. The operator sees it illuminated on the digital twin dashboard immediately. They can go in, correct the programming error, and stop the conflict before any real energy is wasted.
And beyond simply catching errors, we move into precision and predictive maintenance. This fundamentally changes how organizations handle their physical assets. Operators can go into the digital twin and set custom energy benchmarks for highly specific pieces of equipment.
This is where that second-by-second fitness tracker analogy really shines, because the flow of electricity tells the story of mechanical wear and tear long before a machine actually breaks down.
Exactly. If you monitor the electrical current, you are monitoring the physical health of the machine. Let's look at a large industrial motor on a production line.
Okay.
Over time, physical friction increases. A bearing starts to wear out, or a belt loses its alignment. To maintain its required speed against that new physical friction, the motor has to pull more electrical current.
And the system instantly catches that tiny incremental energy spike.
Right.
Instead of waiting for that worn-out bearing to completely fail, which shuts down the motor, stops the entire production line, and causes chaos, the system automatically emails an alert to the maintenance team.
They get a warning right away.
They get an early warning that a specific motor on a specific circuit is drawing 3% more power than its established baseline and needs attention right now.
Think about the operational impact of that. It shifts an entire organization from a costly reactive maintenance model, where you only scramble to fix things when they are broken and smoking, to a proactive, predictive maintenance model.
Saving so much downtime.
You are swapping out a $50 part during scheduled downtime, rather than losing $50,000 an hour in unscheduled production downtime.
It transforms maintenance from a guessing game into a precision science. And that brings us to a third major practical application, which is load management.
Which is a huge topic right now.
It is becoming incredibly critical as the world rapidly electrifies. We are seeing this specifically with managing EV charging stations and identifying unused electrical capacity within existing buildings.
As commercial real estate sectors and municipal buildings rush to add massive banks of electric vehicle chargers to their parking structures, they run into a hard physical wall.
The local electrical grid.
Yes, a building only has a finite amount of power coming into it.
CircuitMeter provides the exact live data needed to manage those EV loads safely. The digital twin can throttle the power going to the chargers in real time, ensuring the building never exceeds its overall electrical capacity.
And it also allows them to identify hidden pockets of unused capacity. An engineer might look at a building's static design plans and assume the electrical panel is maxed out, meaning they would have to pay for a massive, expensive infrastructure upgrade just to add chargers.
But the reality might be different.
Exactly. The real-time data from CircuitMeter might reveal that the building rarely ever draws its maximum load. It finds that unused capacity, proving they can safely add the chargers without the massive capital expense of upgrading the grid connection.
When you step back and look at the aggregate of all these capabilities, catching errors, predicting mechanical failures, managing complex electrical loads, The practical magic of this dashboard is profound.
It really is magic.
An energy analyst or a facility manager can literally, virtually walk through a sprawling facility's complete equipment infrastructure. They can instantly spot energy hogs, misbehaving units, or failing motors hidden deep inside a massive building, all without ever leaving their office.
They get total visibility.
They are granted total illuminated visibility into the invisible forces running their physical world.
It fundamentally rewrites the relationship between human operators and the infrastructure we build. We are no longer making educated guesses or waiting for retroactive reports to tell us what went wrong.
We are interacting with our physical spaces as living, breathing systems.
Exactly, living systems that communicate their needs continuously.
It really is a profound shift in how we manage the built environment. So, let's bring this all together. If there is one high-energy takeaway you should carry with you, it is this. Digital twins are actively moving out of the realm of static, pretty digital models. They are evolving into live, incredibly powerful decision systems that manage the physical world. But they cannot make that leap on their own. CircuitMeter provides the live electrical signal, that 2-second heartbeat needed to tie these virtual models to physical reality. It is the vital layer that makes energy visible and, more importantly, makes it instantly manageable.
Because without that real-time pulse from the circuit level, you are flying blind. But with it, you possess the operational brain and the nervous system required to optimize everything from a single retail store to a sprawling industrial portfolio. The data transforms the model from a simulation into a control tower.
And that transition from simulation to control changes the trajectory of how we manage everything around us. So we want to leave you with a final forward-thinking question to chew on today. We've talked about the incredible power of bridging the physical and the digital and giving our infrastructure a high-speed nervous system. But as you look at this highly connected, automated future, think about where this naturally leads. When digital twins matures, what decisions will humans stop making manually?
And that's it for this episode of CircuitMeter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.